Okay, what's up guys? Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Muhammad Din from ISMP Mathematics. So this is the assignment of multi-variable calculus. I'm going to present to all of you example 7. Okay, and the question is find the angle between the planes x plus y plus z equal to 1 and x minus 2y plus 3z equal to 1. If you guys can't imagine how is the shape, this is the example. For n1 is 1. We take the magnitude 1, 1 and z also 1. This one for the second n2 1, negative 2 and 3z. So this one the n2 is at here 1, negative 2, 3, and for n1 1, 1 and 1. So we got this one. So the question now is that how we want to find the angle between these two lines. So to find the angle we are going to use the formula given. That is cos theta equivalent to this is equation. So n1 cross product dot product with the n2. So n1 is this one, right? And n2 is this one. So what we do is will be multiplying each other. This one just sub the value, and then this one is the magnitude of n1 multiply with magnitude of n2, and we'll get this one, the magnitude, and times this one. So we'll be getting 2 over sec 42. So 2 over sec 42 is cos theta. To find the theta, we will be bringing the cos to the other side. Negative cosine negative 1. 2 over sec 42, and we'll be getting 72 degree. So the 72 degree is the angle between n1 and n2. It answers the question A. Finish question A. Then we proceed to the question B. For question B, we want to find the symmetry equation for the line of intersection L of these two planes. So basically this one, these two normal vectors are a plane, which the first one is this one. This one is the first plane, x plus y plus z equal to 1. Second plane is perpendicular to the first plane, x minus 2y plus 3z equal to 1. So the question is we want to find the symmetry equation for the line of intersection L. But how we want to find symmetry equation if we don't have any point located at the L line? So in order to find the point, we let z equal to 0. So when we let z equal to 0, this one we get from the n1, and this one we get from the n2. We sub z equal to 0. After we sub z equal to 0, we're just going to have two unknowns. That is x and y. So when we have only two unknowns, we can do simultaneous. Yes, simultaneous equation. So we'll do simultaneous equation like normal, and we will get the answer of y and 0. Y and x, I'm sorry. Okay, after we find the value of x, y and z, so basically we got the point that lies at the intersection of L, which is 1, 0, 0. So that is the point that lies on the intersection L. But for intersection L, it lies on both planes, the plane of n1 and plane of n2. Okay, so now we got the point L. So in order to find the symmetry equation, we need to find the vector of n1 cross product with n2. So we're going to use the matrix method. So I, j, k, and then this one is x plus y plus z equal to 1 for n1, and for n2 x minus 2y plus 3z, the formula just now. Then we're going to use the normal method, and we'll be doing, okay, we cut this one, then all the methods of matrix. Then we'll be getting the vector is 5i minus 2j minus 3k. So basically when you got this one, from the formula, we'll be going this we're going to use this formula for us to find the symmetry equation, because we got the vector already. So using the for symmetry equation, to find the symmetry equation, we're going to use this formula: x minus x naught over a equivalent to y minus y naught over b equivalent to z minus z naught over c. So x naught, y naught, z naught is the point that lies on intersection L. So x minus 1, y minus 0, and z minus 0, right? But this one, 5, negative 2, and negative 3, we got it from the vector. So for 5, we sub in A. For negative 2, we sub in B. And negative 3, we sub in C. So when we got this one, that will be the answer. So using this formula, after you got the vector, you will be sub in the vector. And the x0 will be the point that lies on L. So when we get this one, this is what we call as symmetric equation for the line of intersection L of these two planes. So that's all requires in this question. Thank you so much.
Selamat pagi, nama saya Linda Khususana Student. Pada hari ini saya akan membentangkan soalan nomor 8, yaitu find a formula for the distance d from a point P1 to the plane at ax plus by plus cz plus d equal to 0. Okay. Firstly, kita perlu buat satu plane untuk menunjukkan raja untuk P1. Okay. Sekarang kita sudah dapat P1 dan kita perlu satu lagi poin untuk kasih combine dengan P1 supaya kita boleh dapat cari normal vector. So kita letak poin di sini yaitu P0. Jadi untuk mencari normal vector ialah dengan cara kita menggunakan formula distance, yaitu magnitude of vector n dot magnitude a dot dengan vector b. Lepas itu bahagi dengan magnitude of vector n. Cara untuk cari distance ialah P1 minus P0. Yaitu kita dapat cari P1 adalah ini tolak dengan P0. So kita akan tolak dia x1 minus x1 y1 z1 minus x0 y0 dan z0. Dan kita akan dapat ini. Jadi kita dapat distance adalah ini. Terusnya, untuk mencari nilai nomor vector, kita tahu equation of plane adalah vector n dot vector b. Kita dapat equation of plane di sini. Jadi cara mencari vector n, kita just keluarkan nilai vector itu vector n di bawah dan kita akan dapat vector n. Sekarang kita mau cari magnitude of vector n. So kita boleh tahu magnitude of vector n adalah ini. Oke, seterusnya untuk mencari distance of d, kita menggunakan formula yang tadi. Yang ini kita combine-kan semua. Jadi magnitude n adalah ABC, magnitude of d adalah ini, dan magnitude of vector n adalah yang ini. So kita selesaikan macam biasa, yaitu kita garap masuk E dan pergi sini untuk X saja, dan B untuk Y, dan C untuk Z. Dan magnitude of vector n kita akan cekalkan sampai akhir, sampai jawaban. Dan kita akan selesaikan sampai dapat jawaban x1 plus b y1